In April of 2020, a captivating image recorded by NASA's Solar and Heliospheric Observatory ignited wide debate among those intrigued by the possibility of extraterrestrial activity. The photograph, taken by the LASCO C3 camera, seems to show a sizable cube-shaped object situated close to the Sun. Its noticeable geometry and placement in the immense expanse of space have stoked speculation about what it might be and why it could be there. The image quickly circulated into various online communities and groups devoted to UFO research. Within these circles, many noted that cube-shaped anomalies have occasionally been observed not just near the Sun, but also close to the Moon. What renders these reports even more puzzling is that some viewers assert they have observed these cube-like shapes shifting around the Moon when reviewing footage or images from space observatories. Quick pause here. If this story's grabbing your interest, tap like and subscribe. It really helps me keep bringing you these tales. Such claims have heightened the mystery, implying that these shapes might be under intelligent control rather than being random cosmic debris or image artifacts. Over the past few years, respected scientists such as Avi Loeb, a Harvard University professor of science and a well-regarded theoretical physicist, have grown more receptive to the idea that interstellar visitors might exist. Loeb's public remarks about the possibility of extraterrestrial technology, particularly regarding unusual astronomical objects, have encouraged many to entertain that these sightings could represent probes dispatched by advanced civilizations. The cube's perfectly angular appearance has prompted some to reject the idea that it is a naturally occurring object. Nature rarely forms such symmetrical shapes in space without some form of specific geological or artificial process. This has produced the provocative theory that it could be an advanced probe, analogous in concept to the ones humanity has launched to other planets in our solar system, such as Mars and Jupiter. The notion that advanced civilizations might dispatch probes is not merely science fiction, but also a plausible concept grounded in logic. Human history already supplies a template for this kind of exploration. Our own missions, Voyager, Pioneer, and New Horizons, have demonstrated that probes are invaluable instruments for learning about distant worlds without the need to send human crews. Probes can withstand harsh conditions, operate without life support systems, and continue functioning for decades, all while traversing immense distances. If humanity, a relatively young technological civilization, can devise machines capable of leaving the solar system, then it stands to reason that older and more advanced civilizations could construct far more capable devices. These might include self-repair capabilities, artificial intelligence, and possibly even methods of communication or travel that surpass our current understanding. A probe of such sophistication could readily remain operational for centuries, gathering data and relaying it across light years. From a theoretical viewpoint, sending automated probes is sensible as an initial step in interstellar exploration. The distances between stars are so vast that crewed missions may prove impractical, especially for civilizations without faster-than-light travel. Probes, on the other hand, can be dispatched in large numbers to survey multiple star systems simultaneously. They could employ gravitational assists to gain speed or utilize propulsion systems far beyond our present capabilities. Some scientists have even entertained the possibility of von Neumann probes, self-replicating machines that could fabricate copies of themselves using raw materials found on planets, asteroids, or moons. In this manner, a single probe could seed countless others, gradually mapping and monitoring vast regions of a galaxy without requiring ongoing support from its creators. Such a system might clarify why objects of peculiar shapes, like the cube near the Sun, may appear in various locations within our solar system over time. It is also plausible that these probes might be designed to operate covertly, revealing themselves only under certain circumstances or taking forms that could be mistaken for natural phenomena or technical glitches in imagery. The cube's abrupt appearance in solar and heliospheric observatory images, followed by its disappearance in later frames, has led some to propose that it may have remained stationary for hours before moving away, or perhaps even departing the vicinity entirely. Skeptics contend that anomalies like the cube could stem from pixelation errors, cosmic rays striking the camera sensor, or digital processing artifacts. While such possibilities are genuine, proponents of the probe theory point to repeated sightings of similar shapes over time as reason to remain open-minded. The fact that these shapes have been reported in multiple contexts near both the Sun and Moon suggests to them that there may be more to the story than technical glitches. If the cube were indeed an artificial construct, its location near the Sun could yield strategic advantages. The Sun's position in the solar system offers a unique vantage point for observing planetary orbits, solar activity, and potential deep space traffic entering from beyond. An advanced probe might exploit this position to collect data, harness solar energy, or simply remain concealed in an environment hostile to most forms of detection. In the end, the photograph of the cube-shaped object close to the Sun remains unexplained. It sits at the crossroads of science, speculation, and mystery. For those who view it as evidence of advanced technology, it provides a tantalizing hint that humanity may not be alone in its quest to explore the stars. For those who approach it cautiously, it stands as a reminder that not all anomalies in space imagery should be accepted at face value, and that careful analysis is required before drawing conclusions. What is certain is that this image has rekindled public curiosity about the possibilities beyond Earth. Whether the cube is an extraordinary example of alien engineering, an advanced interstellar probe, or simply a quirk of camera technology, it motivates continued observation, deeper investigation, and open-minded discussion. Until definitive answers are obtained, it remains an absorbing mystery, one that reminds us that the universe is full of surprises, many of which may still be waiting to be uncovered. Over the past several years, NASA has issued dozens of photographs taken by solar observatories that seem to show mysterious cube-shaped objects positioned near the Sun. These unusual shapes have provoked curiosity and debate among researchers, enthusiasts, and those who study unidentified aerial phenomena. The cube form, with its crisp angles and geometric precision, stands out in a setting dominated by the chaotic, swirling patterns of solar plasma. Such sightings represent a distinctive and unexpected facet of the ongoing conversation about unexplained objects in our cosmic neighborhood. The Sun's environment is intensely active and dynamic, marked by immense magnetic fields, frequent solar flares, and intense bursts of energy. It is a place where temperatures surge to extremes and radiation levels would overwhelm most known technologies. For this reason, the notion of structured, cube-like objects appearing in close proximity to the Sun is especially compelling. If these shapes are genuine physical objects, their presence challenges current scientific understanding, raising questions about their resilience, purpose, and origin. At the same time, scientists acknowledge that capturing images in such a volatile and energetic environment carries inherent challenges. Instruments used to observe the Sun, whether on spacecraft like the Solar and Heliospheric Observatory or other solar missions, must process immense amounts of light and radiation. Under such conditions, the possibility of visual anomalies is considerable. Optical artifacts, glitches in imaging systems, and interference from cosmic rays can occasionally produce shapes, including cube-like formations that do not correspond to real objects. In some cases, gaps in data transmission or errors in image processing can create patterns that mimic artificial structures. Yet, the speculation surrounding these sightings is not easily dismissed. The notion that cube-shaped objects could represent advanced technology is an enticing, though highly speculative, prospect. If such objects are indeed evidence of an extraterrestrial presence, it would raise profound questions about the motives and capabilities of those who created them. Why would such entities operate close to the Sun, a region so hostile to most forms of matter and machinery?
Could the Sun be a strategic point for energy collection, scientific observation, or as a vantage point for monitoring the planets within our solar system?
In considering such possibilities, the scientific community stresses the need for rigorous analysis. The presence of cube-shaped forms in solar imagery demands careful investigation to differentiate between true anomalies and explainable phenomena. Researchers examine sequences of images, compare data from different instruments, and analyze light spectra to determine whether these objects behave like real physical bodies, or whether they can be ascribed to known issues in data acquisition. This process requires patience and prudence, as premature conclusions can mislead both the public and scientific discourse. The search for answers could also prompt advances in observational technology. If scientists aim to resolve the true nature of these cube-shaped sightings, they may develop new instruments capable of obtaining higher-resolution data or filtering out interference more effectively. Improved imaging systems and refined data processing techniques would not only assist in clarifying the mystery of the cubes, but also deepen our broader understanding of solar phenomena. Better tools could reveal details about the Sun's magnetic activity, surface structures, and particle emissions, leading to breakthroughs in space weather forecasting and astrophysics. Even if many of these cube-like appearances turn out to have ordinary explanations, whether as optical distortions or fleeting debris, the unexplained cases remain valuable. They prompt scientists to revisit and test their assumptions about how the Sun interacts with objects in its vicinity. If something unconventional is present, it might engage with the Sun's magnetic fields, radiation, or plasma in ways that challenge prevailing models. Such interactions could yield new insights into both astrophysics and the endurance of advanced technologies in extreme environments. As with all extraordinary claims, skepticism is vital. The concept of cube-shaped objects near the Sun has captured public imagination precisely because it offers the possibility of a dramatic discovery. However, responsible scientific inquiry requires a balance between openness and critical evaluation. Multiple explanations must be entertained, from the mundane to the extraordinary, and evidence must be assessed carefully. Each step toward understanding requires transparency, peer review, and the willingness to revise theories when fresh data emerges. Ultimately, the significance of these sightings lies not only in the question of whether the cubes are real physical objects, but also in the curiosity they spark. They push the limits of our understanding and encourage us to observe our nearest star more closely. Whether they are artifacts of our instruments or visitors from elsewhere, they remind us that the universe is full of surprises. The process of probing such anomalies strengthens scientific practice, sharpens technological capabilities, and fuels a sense of wonder about our place in the cosmos. As of now, the mysterious cube-shaped objects observed in NASA's solar images remain unresolved. They sit at the juncture of natural science, technological speculation, and human imagination. Possible explanations range from optical artifacts and sensor malfunctions to advanced probes built by civilizations far older than our own. While conclusive answers are elusive, the mere act of pursuing them expands our knowledge and appreciation of the universe. These sightings remind us that science is not only about finding answers, but also about embracing the unknown and allowing it to steer us toward deeper exploration. In that sense, the cubes near the Sun, whatever they are not just anomalies. They are invitations to keep looking upward, to question, and to seek understanding in the vast expanse of space. Thank you for treading this trail of tales till we travel together again on another adventure.